Hey everybody, and welcome back. Today we are going to be taking one step further into our machine learning tutorials here. We're going to be going over a simple example of unsupervised learning. If that term means nothing to you, make sure to check out my last video where I kind of went over the different types of machine learning and different types of data we would be using. We're going to be going over K-means clustering today. In a very simple example, we're not using any MBA stats, we're just working at getting the basics understood. What K-means clustering is, and this, for example, is what I would use to categorize players by playstyle into different player archetypes. So you will take your data and you will plot your data, and then your K-means clustering is essentially going to randomly select start points for each cluster, and it is going to run over several iterations of clustering, reclustering, moving a data point from one cluster to another until the variance of each data point is minimized within that cluster. So the overall variance of that data set, which is otherwise known as the within cluster sum of squares, the WCSS. So let's go ahead and hop into it. We'll go over some of those terms in a little more detail with some examples you can look at that I'm sure is going to help quite a bit, especially if you don't have a statistics or math background to where you haven't really done any standard deviation variance calculations in a long time. Most people are going to understand what mean, median, mode is, but you get one step past that, and that's something that typically drops out of the brain pretty quick if you're not using it. So, hopping into the code here. We have our normal import statements. There's a couple things we're using here that we don't normally use, as you'll notice if you've been following along. We're going to be importing matplotlib.pyplot as PLT. That's what's going to allow us to just make some basic plots of our data for visual understanding. From sklearn dataset samples generator, we're going to import make blobs. Basically, that's going to auto-create a data set that's separated into the set number of blobs that or clusters, if you will, that we're going to be using just to kind of check and see how this works. And then we're going to be importing the actual K-means algorithm from sklearn. If you don't have these already installed on your machine, you'll need to make sure to do your pip installs. I'll have those listed down in the description for you so you can just copy and paste them in. As well as, don't forget, I have written tutorials on my website, nixniche.net. That's going to have the video with a text description underneath that goes into usually a little more detail than the YouTube description, because I can embed code there as well, so it's much more step by step rather than looking at the video and then reading. So, first thing we need to do is make our blobs, or our data set that we're going to be testing on. So what this is saying is I'm going to create an x and y variable using the make blobs function, where I want n samples. That's 200 data points is all that means, 200 samples. Centers equals 4. That parameter is going to define how many clusters I want. And then the standard deviation of the cluster, it doesn't really matter what you put there. That's just going to dictate how closely packed they are. And then random state equals 0. So in pretty much every machine learning algorithm that I've used, there's a random state variable, or anything that's really randomizing how it looks at the data. Like this is, as a machine learning, it's just making blobs, right? But there's going to be a randomness variable as far as where the blobs are, where the data is at within the blob, right? So defining the random state just means that we're going to get the same thing every time we run it with this random state. So just as an example, I'm going to import that, make our xy's, and then plot our 4 blobs there. Just so you can see, if I make the standard deviation down to 0.2 and do the same thing, they're going to be much more tightly packed, right? If we make it much bigger, it's say 1, they're going to be much more spread out. So we're just going to keep it, we'll probably bump it down to 0.5. So we have our clear, distinct clusters there, just to get a better visual understanding of how this works. So you can see the points that we have. We have our x, and Actually, I believe I misspoke. This x and y is not the xy of the point. The x dataset is going to be the xy of the point, and the y is going to be which blob it's a part of. So if we look at y, we're going to see, blob 0, 1, 2, 3. That's 4 blobs. That's what we requested with our centers parameter. So the x is actually the xy. The y is going to be the blob value. And then we're going to be able to check back against this after we run our KMeans clustering and see if they match up. And just for visualization here, we're going to change the random state to 48. Because if I run this at 0, I can run it over and over again, and it's going to be the same blobs. If I make it 48, now they're different blobs. If I make it 40, now they're different blobs. So that's all the random state is assuring, especially in like a tutorial like this, that we're going to be able to get the same values over and over again for testing purposes. That can come in handy when you're actually using this in your own algorithms for fantasy sports, for example, as we do on this channel, to make sure that you're applying the same thing every time. Because you could run your predictive model, and that's something we'll get into quite a bit down the line. Think of it like a Monte Carlo Think of it like a Monte Carlo simulation, where you'd run your simulation 1,000 times and kind of get an aggregate of potential solutions. Then you can kind of look at how those are distributed and kind of make your best judgment on how you want to interpret that. An easy way to do that here would just be to have, iterating through 1,000 random states, because each one's you're still taking the same data, you're still taking the same analysis, but that randomness that gets applied is going to be a little bit different each time. So it's like, it would be similar to saying, okay, well, Dame Lillard was projected to have 50 fantasy points today. You could run this 1,000 times with 1,000 different random states. You're not going to get 1,000 different answers, but there is going to be variance there. Maybe it ranges from 47 to 65. Okay, well, your first one you used was only at 50, but that's pretty close to the lower level, so you might want to look at him and be coming up and assuming he's going to be getting like 58 to 60. So we'll get into that. Getting way ahead of myself here, just trying to explain that, because that's a strange variable that I didn't understand what it meant or what it did for a very long time that I was using it. So, moving on. We have our scatter plot of our XYs, and we know what blob each one's supposed to be in. Coming down here, we're going to be looking at variance. Okay. And variance is a little hard to wrap your head around if you aren't used to using it. So what you have your mean, okay, everyone knows what mean is, it's just the average. So if we take the average value of every data point in here, that's going to be the mean value. What the variance is for each individual data point is going to be the mean, the data point you're looking at, minus the mean value for that data set that it's a part of, which in this example would be each cluster. And then you're going to take the absolute value of that value, so it's going to be a positive value. You're just looking for the difference, the value of the difference, not necessarily if it's positive or negative. And then you're going to square that value. That's your variance. So, what that would look like, using Python, for instance, would be absolute value. Here, let's say x is our data point. Data point equals 5. Let's say the mean of our cluster is 8. Okay. So just taking this one step at a time, we have our data point minus the mean, which is going to be -3, right? Then we want the absolute value of the data point minus the mean. That's going to be +3 because it's the absolute value. And then we're going to want to take this and square it. And in Python, the double asterisk means square, not the caret as you'd typically see written out. That's going to be 9. So the variance for this data point is 9. Make sense? Hopefully so. If not, let me know down in the comments and I'll try to find a good source that explains it a little bit better. But that process is going to be done many, many times through the KMeans clustering, which I think there's a, let's see, yeah. So there is a little graphic on the Wikipedia page for KMeans clustering. And this is kind of showing how it goes over the different iterations. So you have your blue, your red, your yellows. And let's see, so as it starts over, it's way off. And each time it goes through, it'll change the center and it'll recalculate the variance for each of those clusters. And you can tell every iteration it goes through, it changes a little bit less and a little bit less and a little bit less because it's really zeroing in to where it needs to be. And that's what's going to be happening, is the variance for every single value here is calculated with respect to its center point of the data set, or the mean. And it's just calculating through, and it's trying to minimize that total variance for each data set, and it adjusts itself accordingly until it gets to that point. Which, as you can see, comparing that to our data set, ours is going to be pretty easy. There's a couple kind of flyers out here that fall in between two data sets that it might have to iterate a couple times to figure out, but it's going to be a pretty quick and easy one. So what we're doing here is kind of a two-part way to look at this, because we know that there's 4 blobs, okay? But you're not always going to know how many clusters you need. Think of like the NBA advanced stats. You could pull in a ton of advanced stats and try to cluster that into different player archetypes, and you can decide, I want 5 player archetypes, and that's fine, but that might not be the best slicing of the data, you know? And you want this to be as accurate as possible, so you want to follow the data. That's why unsupervised learning is more for when you have data and you're looking for insights. You want to know what the data is telling you. You're not telling the data what to tell you. So even though we know that there's 4 main clusters, we're still going to go through our process and figure it out. So for visualization purposes, we're going to need a variance value for each iteration here. We're going to iterate through 10 times, remember, because in Python the range stops at the value before the endpoint, so that's 1 through 10 that we're looking at. And we're going to get a KMeans value using the KMeans clustering algorithm, where the number of clusters is this value, I, which is going to be 1 through 10. So we're going to look through up to 10 possible clusters. The maximum iterations it'll go through is 300. That's basically just putting a cap on, okay, if you can't figure it out in 300 clusters or 300 iterations of adjusting those clusters, you're just done. Otherwise, it could just run infinitely if it just keeps ping-ponging back and forth trying to figure out what's best. In initialization, you're just basically telling it how many times you want it to start with a different random starting point within your data set. So we're going to say 10. Random state, again, we're defining as 0, and that's just keeping it the same for each iteration here. We're going to apply this function to our x data set, which remember is just the x's and the y's. And then the KMeans function here has an inertia statement you can pull along with it that's basically just going to give you the variance for that data set after it's put itself into the different clusters. Okay. Once that's done, we're going to plot the variance for all 11 iterations. We'll go ahead and take a look at that. So remember how we talked about calculating variance. So we've got our 1 cluster, obviously has the highest variance because it has all of them in there. So there's going to be quite a few of them that are pretty far away from that mean point. And it's going to drop a little bit with every iteration, okay? But what you want to look for is the last noticeable change in the slope of this line. Okay, and this one's pretty easy. I think it's called, which makes sense looking at it, I think it's called the elbow method, I want to say, is what you'll probably see and different documentations if you're looking around trying to learn more about this. And what that means is where you're looking for that elbow that's going to have the biggest change in slope, because we have this slope here. That's not a huge change in slope. That's not a huge change in slope. That's going to be our biggest change in slope and also the last big change in slope. So the slope difference is basically how much the variance changed by adding the extra clusters, because at some point you're going to have diminishing returns, right? So we can see here, noticeable, noticeable, noticeable. That's a pretty straight line. That's not going to, it is going down, but it's going down at a very small rate. So we like 4, where that basically is what we would be doing if we didn't already know there were 4 groups. So this affirms that we see that, okay, there is in fact 4. So now we're going to take that again, and using the KMeans function, we know that the in clusters is 4. So we don't need to do, you know, this iterating 1 through 10 to figure it out. We know there's 4 clusters. So now we can tell it, this is how many clusters there are. Figure out how to put them in the right cluster, okay? Pred_y variable is going to be the predicted cluster for that XY pair based on our K-means algorithm up here. And then we're going to plot our X's and Y's. We're going to plot the cluster centers as well, okay? So what that's going to show us is our initial data set up here with the X's and Y's. And as you can see, that looks like the center of each data set to me. That's what value we're looking at as the mean value to calculate the variance. And you'll see sometimes, and that's kind of a good ground truthing for yourself going through unknown data sets, is to just kind of make sure that it makes sense, right? Because if our means were way off in the corner of each of these, that something's not right. There's something we're not seeing there that's causing that, which could be if you're using any sort of dimensionality reduction techniques, that could be playing into it. But for this simple 2-dimensional XY variables, it's pretty easy to look at and understand. So you may be thinking, well, how do we make sure that it's correct? Like make sure each point actually got put into its own, like some of these here. I don't know. Is it closer to that one or closer to that one? It looks like it's closer to this one, but that's pretty close, you know? I don't know. So you think, okay, well, let's take the predicted y, or the initial y value for the group, and minus the predicted y. Everything should be 0 if they're the same. Well, if we do that, we can see that's obviously not the case. But you'll notice our values here are -1, 2, -3. Right? So while none of them are exact, this looks like the same distribution of data that we had. So let's look at y. Okay. This was the initial from our make blobs. Okay, these are the blob assignments. Predictive y, we have the same values. 1 to 2, 2 to 0, 0 to 3, 3 to 1, 1 to 2, 0 to 3. Okay, well, we have 1 and 1, 1 to 2, 1 to 2. It's a good sign. So that would be 1 minus 2, and -1 is a value here. So it looks like they might be adding up. They're just not the same numbering for the clusters. So let's check that. So all we're doing here is we're turning this array into a list. Okay, same values. And we're turning the predictive y values into a list, the same thing. We're going to throw them in a data frame. And then if we take a look at that data frame, this is just putting in a table to make it easier to see and compare. Okay, so we need to transpose that data frame because we want it to be going the other direction. So just df.T transposes our data from left to right to top to bottom. Okay, and then for each of these, we're going to take a peek. And what we're doing here is we're creating a new data frame, df1 equals this data frame where the 0th column equals 0. So what we're going to do is we're going to make a data frame for each of the initial y values, pull them out, and look at it and make sure that the predicted y is the same. It's not going to be equal to, but they're all, so if our first one is 0, 3, then everything in this column should be 3. Okay, so that's good. Now let's do 1. And we have 1 to 2. Okay, good. 0, 1, 2, 2 to 0. All right, so we've had 0. What do we have? So we have 2, 3, and 0. 0, 2, and 3. So we have the 0th column equal 3. There's only one value left for that to be, and it's 1s, and they're all 1s. All right, so we have now established that using our clustering algorithm, we have clustered 4 groups here, right? And we have successfully identified the make blob up here at the beginning. Remember, we made a blob with 4 centers. And we have successfully shown that using KMeans algorithm, we are able to predict the accurate cluster type. So even some of these in the middle, they were all put in the correct cluster based on the make blobs tool that we used. So I'm sure you can imagine how we're going to be using this for our daily fantasy work. This process here, identifying how many clusters and things like that, is going to be much more detailed because we don't know how many clusters there's going to be. It's not going to be quite as obvious here. There's going to be a couple other variables that we need to use in order to maximize the return, basically, get it as accurate as possible. So we've got a long way to go, but this is a good first start just to kind of understand what K-means clustering is doing. And again, if we went too fast past anything, I do recommend just take a look at the K-means clustering Wikipedia page. That's going to be the end of the video today. As usual, if you guys like what you see, give me a like, give me a subscribe. If you have any questions about this, do comment below. I do a pretty good job of reading the comments and providing help and insight when I can. As well as I've had several folks be emailing me some of their code if they're unable to figure it out, what's causing an error, something's going wrong, or it's not matching up with what they're seeing in the tutorial. Do feel free to shoot me an email. I'll put the email address down in the description. If you are going to send me an email, make sure to leave a comment on the video and let me know you're sending an email, and let me know the subject line of the email. Because while I do like to go through and help folks out, as more and more people start reaching out with help, sometimes it does take a little bit of time to figure out what's going on in there. And I do very much enjoy to help, but it also is a bit of a time crunch to get some of these videos out on a schedule that I am happy with. So I will always prioritize making the videos and updating the blog over answering the emails. But when I have time, I'm definitely more than willing to help out. So thanks everyone for your support, and I'll see you in the next one.